Okay, let's take a quiz over what you've learned today. So question number 1, if these two waves were added together, what would happen to the amplitude of the resultant wave, and what kind of interference is this? Okay, so what you're going to find is you're adding, when one of the wave is at its maximum, the other wave is at its minimum. So when you add them together, you get nothing. So that this is going to be an example of destructive interference. So when you add a wave that's going up to a wave that's going down, then they both cancel out and you're ending up with nothing. Question number 2, how many nodes does this wave have and how many antinodes does it have? So the node is going to be where the thing is coming together. Okay, so that it's going down and up and then down, and then it's going down and up and then down like that. So you got a node, and then a node, and then a node, and then a node. So this one has 4 nodes. Okay, how many antinodes does it have? So that's going to be where it's going to be having maximum, and so that's going to have an antinode here, and one is going to be here, and one is going to be here. So this one's going to have 4 nodes, and then it's going to have 3 antinodes. Question number 3, what does the amplitude of a sound wave correspond to in music? That's going to be the loudness. Number 4, what is the frequency of a sound wave in air if it has a wavelength of 3 meters? So we're going to use that the speed of a wave is equal to its wavelength times its frequency. So the speed of sound in air is going to be 340 meters per second. And then we are told that it has a wavelength of 3, and we're trying to find the frequency. So 340 divided by 3 is 100 and something. I'll let you do it. So 340 divided by 3, and then that's going to be the frequency in what units? Don't forget to tack on the unit. That's going to be the hertz. And then finally, we got question number 5. What does the cochlea do in an ear? So what's the purpose of the cochlea? Okay, it's to take the sound waves, which are in the form of a vibration, and convert them into an electrical signal, which then travels down the auditory nerve to the brain for processing. Okay, so we're pretty much now finished with mechanical waves. So in our next lesson, we're going to start looking at light waves. So I'll see you then.